Yeah.
All right then. So I assume everybody knows how to convert from from binary to decimal and vice versa. Oh, well,
Yep.
everybody's muted. Yeah, I'm just going to assume that. And we'll see that this table has 8 rows. Each row has a different thing hidden. For example, in the first row, the IPv4 address is given, and first host and last host is given, and this network connected to any other network. The first thing about this network connected to any other network is irrelevant in all cases except for this one, number of addresses usable. And I'll show you. But all that matters is the relation between broadcast address and address of last host. So first of
Is that
all,
the ratio?
ratio? No, the ratio is
Is
later. That's in another, I think attenuation, that kind of question. Here, there's nothing related to ratios. So we'll just start with, do you know what a net mask is? Address mask? Well,
No, bro.
yeah, I'll start with the IPv4 address then. The IPv4 address is 4 numbers. Each number can be, each number goes from 0 to 255, which is basically 8 bits. So the maximum, and it's 4 numbers, so it could be like 3.4.5.196. It's a valid address. So this could be written in like actual binary. It's like 0, 0, 0, 0. You'll be doing a lot of conversions when you're solving the questions. So 0, 0, 1, 1. And I don't know what 4 is, but it's like 8, 8 more, dot 8 more, dot 8 more. Just keep going like that. So what the net mask does is an IP address has 2 parts. One part identifies the network. So for example, here, this 1.6.128.33, right? And the last host is 1.6.128.61. So this is not the whole host network card, but this is just an example. So imagine this part is the network part. It identifies the network. And this part is the host part. It identifies the hosts like uniquely. So, however, in the decimal view, this isn't very accurate. You'll have to see it in binary and compare it to the net mask. So what all the mask does is it tells you, or it tells the computer, which part of the IP is the network part and which part is the host part. And the net mask can either be written in like IP notation like this, or more modern. And here what we will be doing, if we are required to find the mask, we'll always use the CIDR notation, also called the slash notation. I guess this will be like this will be 24. And all 24 means is convert this mask. If you want to convert this mask to binary, it will be a 255 is the maximum 8-bit value. So it will just be 8 ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. And this is just. So the reason this is slash 24 in CIDR notation is because this mask is 24 ones in a row. So you can also write it as slash 24. So now, how can you find the network part and the host part using a mask? Let me look up the shortcut for brush and paint. And if you have any questions so far, just let me know.
So is the slash 24 only if all the ones are in a row? What happens if it's like 255, 255, 255, and 3? 3 in binary is 101, right? So would that be 20, like slash 26 or slash, what would that be in CIDR?
You just convert it to in a mask, the ones will always be in a row. So you just convert it to binary and see how many ones there are in a row.
Okay.
You look at the example, you'll see that in the masks, 255, 255, 224, it's still ones
Mhm.
in a row. And slash 28, slash 19, slash 23 are all ones in a row.
So once in a row, left to right.
Yep, left to right.
Okay.
Which is, oh, that's Corel Draw. There's no shortcut. That's my bad. Right, so we can see that an IP address given in this is 31.6.128.41. So
Mhm.
this IPv4 address colon just means that this is one of the IP addresses in the network. It could be anything. It's just an IP address. So we'll write it down, 31.6.128.41. All right, and the net mask for this is, well, it's not given. So if the net mask isn't given, I'll say, for example, the net mask is slash 15. For example, if the net mask is slash 15, so then we will have to compare this IP address with slash 15 to find out what is the network part and what is the host part. So for to convert an IP address to binary, you have to convert all the numbers to binary. So we'll start with converting 31. So I convert it to binary like this. You can choose your own method. 15, 30, 14, like this. So, uh, so 31 is 11111, and we'll have to make it 8 bits. So it will be, since this is 5 ones, 31 in 8 bit is 0. We just add as many zeros as we need to make it 8 digits. So now 1, and then, so that's 31. 31 to find. So yeah, it's correct. So 31 is this. I'll just make it bigger. So we already got 31. We'll just convert 6 real quick. So 6 is 110. To make it 8-bit, we'd have to do 1, 2, 3, 4, 5, 110. So this is 6. 128 is When you do the table a few times, you'll know it by heart, but I'll just do it manually the first time. I think 128 is just 0 and all the other ones. One, two, I think 60 gets 120, 64.
It's 1100.
16, right? Yeah, 15 gets 16. 0, 2, 8, 16. 0, 2, 8, 2, and then 1. So 128 is actually no, I messed up. It's 1 and then just zeros. So it'll be 1, 2, 3. Okay, it's already 8 bits, so we can say 128 is 1. Yeah. Okay, and then now we just need 41. No, 41 will no, this is it. Actually, you already know the method to do it, right? I'm just going to do it on my notebook. It's faster.
Yep, that's okay.
Yo, Sadman, the chief guest is here as well.
He's still configuring his audio and stuff.
I just wanted to flex on us, his presence.
He's making sure we're studying right.
Making sure we know he's there.
Yeah,
Yeah, if somebody's watching this video from the future because this meeting's being recorded, Sadman's the guy who taught me how to do this. He's the OG.
it's good because we can later check on the steps if we want to like remind ourselves.
41 is 101001. So it's 6, right? So you will just put 2 zeros at the start and then just 101001. So now we have all the 4 digits in binary. So now we just write it down. The IP address is, let me just increase the brush. So, oh, paint sucks. What are these controls? Uh, it's 31.31, right? So 0, 0, 0, 1, 1, 1, 1, 1, 0, 0, 0, 0, 0, 1, 1, 0. 128 is 1 and 7 zeros. And 41 is 0, 0, 1, 0, 1, 0, 0, 1. So this is the IP address. Now we'll write the, like in this example, the net mask is 15. So 15, we just write 15 once and then the rest is zeros. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and the rest just zeros.
Did we
So
have 15 ones in this
4,
address?
1, 4, 8, 12, 13, 14, 15. Yeah, 15 ones. So what the mask denotes is where the network part ends and the host part begins. So So now if you look at it, the ones end here, right? That means this part of the IPv4 is the network part, and the rest is the host part from here. Is it all clear until now?
Yep.
Because we'll be using this comparison thing for the rest of the table. It's the basis.
But in the table, there was no host part. I mean, the net mask wasn't given. It was
Yeah,
empty.
this is in the table. I'm just giving an example. Like, what if it's 15? We'll do this. In the table, we're actually supposed to find our own net mask, which we will do. There's a method. It's comparison again, but now you know how to convert, right? By the way, this meeting's being recorded, so you know, if you forget something, you can just watch the video again. So
Of
now
course.
we can see, you can see the picture, right?
Yeah.
So for the first row, we are given address of the first host in the network and the address of the last host in the network. So for this, what we do is we compare these two and we find out how many bits they have in common, and that will be the net what do you say?
Net
That
mask.
many bits will be the net mask, because you know the network part doesn't change, right? So the amount of bytes they have, the same bytes will be the network part, and the bytes that change will be the host part, because the host part is to uniquely identify every machine. So if it's not unique, they
Mhm.
can't identify all the machines. So I'll just show you with an example. The first one is 1.6.128.33, and the other one is 1.6.128.61. All right, so we already converted 1.6 to 128, right? Now just convert 33 and 61. I'll do it using a calculator app because you know, I'm just here to explain. But you should practice conversions until you can do them in like a minute. So the first IP, I'll write it down in 8-bit. Actually, you don't even need to do it. I just remembered. See, the three octets, by the way, each part of the IP is called an octet. So this has 4 octets. Octet is because octa means 8 and each part is 8 bits. But anyway, the 3 octets are guaranteed to be same, right? We don't even need to do anything. This is 8 bits. This is 8 bits. This is 8 bits. So 8 multiplied by 3 is 24. They already have 24 bits in common. So all we have to do is compare these two, because in decimal, it looks like they have nothing in common. But if you compare them in binary, they might have some bits in common. So first, let's compare 33 with 61. 33 is 1000001. So we had 2 zeros at the start. 0001. This is 32. And then 61 is 111101. So we had 2 zeros at the start to make it 8-bit. 111101. All right. So can you tell me how many bits they have in common?
2 or 3. Oh, actually
Yep.
4.
3. It's here.
4. Right?
You stop counting at the first one where it's uncommon. Even though this 0 and 1 is common, we don't count it. It stops being
Okay.
similar at this 0 and 1 discrepancy. So it has 3. So now we look at the amount of bits, like 24. 24 were common anyway, and then 3 from this last octet. So we add that up, 24 plus 3, and that will be the net mask slash 27.
27.
So now you have the net mask already. It's slash 27. Okay, so now you can write the net mask on the top. So you can write the net mask here on the table as well. So now that you have the net mask and you have the IPv4 address, you have to find the broadcast address. So for that, I'll show you. First, you have to find the network ID for, well, no, you already have the first host. You don't need to find the network ID. But I'll show you that template where you can find both the broadcast address and the network ID. So just to clarify, network ID is an IP address. For example, it normally looks like this. And you can find the first host from the network ID. So I'll show it to you in row 3. But yeah, for now, you have the mask, which means you can find out the network part and the host part, and you need to find the broadcast address. So I'll just write down this 31.6.128.41. This is an IPv4 address. This is the mask. So what do you think 27 means?
27 ones in a row.
Yep. So 31. 31 is 5 ones. So to write 31, it would be 31. 6 is, I think, 3 ones. Let me see. No, it's 110. So 5 zeros and then 128 is like you need to remember it. I just forgot because I'm dumb, but okay, it's 1 and 7 zeros. 1, 2, 3, 4, 5, 6, 7. And 41, it's 101001. So you add 2 zeros. Or 1001. All right, that's done. So now the easy part, we can just write the mask is 27 ones. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. So this is the cutoff. So we can see in the IP address, this is the network part, and this is the host part. These 5 bits. So from this, we can get both the network ID and the broadcast ID. So network ID, I'll show you later. But for broadcast, all you have to do is make all of these host bits into ones. Like it doesn't matter if it's 0, 0, 0, 0, 0, you make all of them ones. So to make it broadcast, you just have to make all of them ones. So I'll rewrite this. Another thing about this is you only have to change the last octet. You don't have to rewrite the first 3 numbers. So the last octet is the only one changed. For example, if the host part was starting from here, you would have to rewrite the last 2 octets. If it was from here, again, last 2 octets. Here, then last 3 octets. You get what I mean? So now you just have to rewrite the last octet. So the last octet was 00101001. But now, first you write the network part, which is 0, 0, 1, and after that it's a host part. So that means all of it becomes 1, 1, 1, 1, 1, 1. And then you convert this to back to decimal. So with this, the method for it is this, right? 2, 0, 0, 1, 2, 3, 4, 5. So you do 2 raised to the power 5 plus 2 raised to the power 4 plus 2 raised to the power 3 plus 2 raised to the power 2 plus 2, 1. So Salman told me about this method where you can just do 2 raised to the power 5 plus 1 minus 1. This goes like if you have a sum where you have 2n plus 2n minus 1, and it goes all the way to well, I forgot where I wrote down, but I think it's like it goes to 2 1 plus 2 0 like this. So you can write this as 2n plus 1 minus 1 instead of doing the whole long calculation. So it's 2 raised to the power 6 minus 1. Another thing that you should memorize before the exam is the powers of 2 from 2 0 all the way to I think 2 8. So that would be 1 2 4 8 16 32 64 128. You can do even more if you have the capacity. Like I know until like 2048. So it's 128 256 512 1024 2048. So until then, but you should know at least these ones. This is the 20 1 2 3 4 5 6 7 8. So anyway, because I know that, I can just say that 2 raised to the power 6 is 64 minus 1, it will be 63. So the last digit of the broadcast IP will be 63. So now we can just write the broadcast IP. It goes like the first 3 octets are the same, right? So we go like 31.6.128.40, well, not 41, but 128, and the last one will be 63. And that's it. That's your broadcast IP. Or what else do we need to find? Okay, number of addresses usable for the end node interfaces. So here, first you need to see if the network is connected to any other network or not. And you also need the address mask. That's it. These are the only 2 things you need for this question. So the formula for this is 2 raised to the power 32 minus CIDR. CIDR is this. This is called the CIDR notation for the mask. Minus 2. This minus 2 is for the broadcast and network ID, but you just have to memorize the formula. It's always minus 2. And now if the network was connected to another network, you have to write number of routers. If it's not connected, for example, row number 2, row number 4, row number 7, row number 247, then you don't have to write this. But yeah, otherwise, this is the formula. You can find it in
But
the
you
group.
said
It's
that
in the
part
notes.
was not
Yeah,
needed. You said that part, that column was completely useless before.
yeah. I said that it was completely useless except for this question.
Okay.
So it's only for this. I mentioned it because, you know, when I started doing the table, I was looking at this and it looked very intimidating. But apparently it's a useless column. It's just there for one more answer. So yeah, it's just this formula that you got to follow and it should be solved. Another thing is for the answer, you don't even have to do the multiplication. I mean, if it's something simple like 2, 6 minus 2, then of course, you know, it's 64 minus 2 is 62. But if it's something like 2 raised to the power 30, don't waste your time on that. Like here, it's 2, 32 minus 27. Okay, 29, 30, 31, 32 is 5. So this will be 2 raised to the power 5 minus 2 minus routers. 2 raised to the power 5 is 32. 32 minus 2 is 30. So the answer will be 30 minus routers. By the way, I already have the whole table solved and I posted it on the networks group. So you can just check there if you want to ever check back. So this is row 1 and the meeting is about to close soon. Let me look at the timing. Yeah, it's 5 minutes left for this meeting. So we'll end it after some questions. So do you have any questions about row 1?
All the questions like these, or can we expect something new like what Adam did with databases?
Yeah, Gal Zoltan never changes his exams. And Sadman, he told me that he never really changes the pattern. For example, in the first row, the 3 octets are
And
always the same.
what's the
Second row, he
supernet
changes the
about?
3rd octet. Yeah?
What's the supernet about? Like the first
First?
column. Yeah.
Oh, that's row 7 and 8. Don't worry about it right now. For now, worry about row 1.
Okay.
Once you know row 1, the concepts in row 1 and row 2, trust me, supernet, it looks scarier than it is. It's extremely easy. Like these rows 7 and 8 are the easiest rows of the whole table. I know, like, because it has the word super in it, you think it's some scary shit, but it's not. So row 1, you
So
got
this
any
is like
problem?
super sane or something.
Yeah. So anybody, Abhijit, Betik, was any problem about first row?
No, good.
I don't think so.
All right then. So I'm gonna close this meeting now because we're gonna close in 4 minutes anyway, and then I'll send a new link to the group. So see you guys.